on talking about coterminal angles. We did this warm-up in class. Let's see if I can get it. So we did this example in class, and then we did this warm-up. So you could do it this way mathematically, or we could draw that picture, and it will make a little bit more sense. So make sure you do know how to draw the picture. That is what I'm going to ask you to do on the test. Okay, so we're talking about coterminal angles. To find an expression that will generate all angle coterminals given, you would just take the integer multiples of 360 and add that to the given angle. So for example, if you were to do a 60-degree angle and you wanted to find 4 rotations away, you would do 60 degrees plus 4 times 360. So we're going to use that idea. That's how we solve for these type of questions. Okay, so here's that example. Go ahead and get that in your notes if you'd like it. Here's another example of what I was talking about, and we'll get to those later. Okay, so what I would like you to do is put all of these in your notes. Put this triangle in your notes. This is in standard position. The reason why we're going to call the bottom x is because x is on the x-axis. The reason why we're going to call that side length on that side y is because that is along the y-axis. Another thing that these things could be called, let's see, we could call this one A. Oops. So if we want to do side length A would be directly opposite of that, so y could also be side length A, and then x, oh I see right here, you guys actually can't see this, there you go, x could also be side length B because that is opposite B right there, and opposite of this would be C. So that is how you would do that. Okay, so we have SOH-CAH-TOA and her reciprocals. She's the lead senior, SOH-CAH-TOA, and the reciprocals are the flip side, her backup dancers. Just kidding. But that's something that I use to help me. So sine, so, is opposite over hypotenuse. So if we were talking about this triangle right here, if we were looking at the sine of A, the opposite would be right here. So it's the opposite of the angle. Opposite of the angle. And the hypotenuse is always the hypotenuse. That one's going to be opposite of the right angle. So get this in your notes because we're going to use this a lot. Okay, so when we're talking about the sine of A, we're saying that that is going to be the opposite. So for this particular triangle, that's going to be y. So that'll be A over the hypotenuse. And then the cosecant is just going to be the flip of that, the flip side of that. So it's going to be the hypotenuse over the opposite. So go ahead and get that in your notes. We're going to do the same thing for cosine. So the cosine of A is going to be the adjacent. So the adjacent side of an angle is the side that shares, helps make part of that angle. It's adjacent, so sharing it. So the adjacent is going to be that x, and then the hypotenuse is still the hypotenuse. And then the reciprocal of cosine is secant, so we flip it. And then the last one is tangent and cotangent. So we're going to go ahead and put those in our notes. And we are going to do an example. So if we were to find the 6 trig ratios for this, for the sine of A, I do this the same way every single time. So I'm going to sine of A, cosine of A, tangent of A, and then the reciprocal of sine is cosecant. Oops, I forgot the A. And then the reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So now I'm going to do that. So I remember SOH-CAH-TOA. When I was learning this the first time, I wrote this on the top of my paper. SOH-CAH-TOA. SOH-CAH-TOA. My dog's name is Ahsoka, so I reference her as SOH-CAH-TOA all the time. I call her SOH-CAH-TOA all the time. Okay, so now what I want to do is start labeling. So this triangle does look different. If I were to label these, like if I were to give side lengths, I would do A. I would make this side length A because it's opposite. And if this were C, I'd make this side length C because it's opposite. and B, this is going to be opposite, so like that. That's how I would label it if I were using A, B, and C. Since this is just a triangle, that's what I'm going to do. Okay, so now I know that. Since A, I'm going to be talking about the opposite side of A, opposite. And we said that C, the hypotenuse is always opposite of the right angle, so this is the hypotenuse. And then this is making up part of angle A, so this must be the adjacent. So now all I have to do is figure out what they are. So sine of A is opposite over hypotenuse. The opposite is 7. The hypotenuse is 25. This is going to be the reciprocal, so it's going to be 25 over 7. Cosine is going to be the adjacent, so the adjacent is 24 over 25, which is the hypotenuse, and then I'm just going to flip it here. And then the tangent is the opposite, which was 7, over the adjacent, which is 24. And then this is just flipped. That's it. That's all we're doing. So what I'd like you all to do is I would like you to hit pause and do it all for angle B. Okay, so I have my 6 trig ratios set up. I know I'm going to do sine, cosecant, cosine, secant, tangent, and cotangent. Now I need to find the hypotenuse. So that is going to be this side. It's the same triangle but different angle. Now the opposite side of B is right here, so this is different, and the adjacent side is now 7. Okay, so now I'm going to find everything. So the sine is going to be SOH-CAH-TOA. So opposite over hypotenuse, that's going to be 24 over 25. Then I'm going to flip it, 25 over 24. This one is going to be cut, it's adjacent, so 7 over 25, and then 25 over 7. And then the tangent ratio is going to be the opposite over adjacent, TOA, opposite over adjacent, so 24 over 7, and this will be 7 over 24. So notice that the hypotenuse never changes, but the adjacent and the opposite sides do change based on the angle. The angle tells us whether it's opposite or adjacent. Okay, so, all right, that is where we're going to stop. Go ahead and make sure that you take all this down, and if you have any questions, let me know.